This is Geometry, Lesson 5.3. For the rest of this chapter, we're going to be looking specifically at quadrilaterals, and today, kites and trapezoids. So all four-sided shapes, kites and trapezoids on this lesson. The first shape, trapezoids. We should know a trapezoid has two parallel sides. The other sides could be congruent, they don't have to be, but it does have to have two parallel sides. So I see AD parallel to BC, I know this is a trapezoid. My first conjecture states that the base angles of an isosceles trapezoid are, here's a base angle, here's another base angle. If this is an isosceles trapezoid, they are congruent, just like on an isosceles triangle. But we actually have two sets of base angles on an isosceles trapezoid. A and D are also congruent. The next conjecture is the consecutive angles between the bases of a trapezoid. So consecutive angles would be like angles A and B, they are consecutive. Or D and C, they are consecutive. And they will always add up to 180 degrees. So my technical term for that is supplementary. But I think it's probably a good idea to add that it adds up to 180 as the meaning of supplementary, so we don't forget what that means. I have one more here. It says the diagonals of an isosceles trapezoid are blank. So I'm going to scroll up and I'm going to add some diagonals. Diagonals would be straight segments connecting D to B or A to C. And so I'm going to do my best to draw a straight line, but it's not going to work very well because it never does. I'm just trying to connect across the middle there. But anyways, what we should notice is that they are the same length. Going from A to C, going from D to B, they are the same length. I have one example doing a trapezoid, finding some measurements. So my picture here, I'm trying to find X and I'm trying to find Y. I have an isosceles trapezoid. I know that the base angles of an isosceles trapezoid are congruent, so I know right off the bat that Y should be 56 degrees. And if you can look at these trapezoids, I mean, the conjectures are pretty intuitive. If you just think about, this is symmetric, reflect the image across, and the numbers match up. So I'm going to now try to find X. The second conjecture I wrote down told me that consecutive angles will always add up to 180 degrees. So since I have 56 in this corner, if I do 180 minus 56, I'll get the answer for X. That'd be 64. And 124. Some students don't like to do it that way, so I'm going to give you another option. If you choose it, we should remember that the four angles of a trapezoid will always add up to 360. So I know I have 56 so far in one corner, 56 on another corner. That is 112. I can do my 360 minus 112, and that is 248. And then because I have two angles left over, I got the same answer of 124. This is the way that our new conjecture is telling us to do it, but if you feel more comfortable doing it the way we were doing it in 5.1, you can keep doing it that way too. So we're only half done because we finished talking about trapezoids. We still want to talk about kites. So here's a kite. Kites were defined by two consecutive congruent angles, or sides, my bad. Consecutive congruent side sets. So I have the one matching up on the right and the twos matching up on the left. The vertex would be like the top and the bottom of the kite, since my kite's kind of oriented on its side. We got that right there. And then the non-vertex would be the sides right here. Okay, so think again about that symmetry. I have a congruent side here, congruent side here, congruent angle here, congruent side here, congruent side here. if I can imagine this diagonal right here, everything on the top and the bottom, the way I have it drawn, would match up. So this non-vertex angle and this non-vertex angle, they're going to match up as well if I fold that in half. The non-vertex angles of a kite are congruent. My second conjecture states the diagonals of a kite are blank. So I dotted this one out. I'll draw it in properly. And I'll draw my other diagonal in right here. Those diagonals will always form a 90-degree angle. So when I'm looking at a kite, I can say, yep, I got a kite, it adds up to 360, I can see all the symmetry. But if I really needed to, I could also split it up into 4 right triangles. Now I have 4 right triangles that each add up to 180, and I can do some other stuff with those. My next conjecture states the diagonal connecting the vertex of a kite, the diagonals connecting the vertex angles of a kite is the blank of the other diagonal. Okay. So it's saying that this diagonal here is exactly cut in half by this diagonal here. So our proper word for cut into 2 equal pieces is bisector. So not only do I have 4 right triangles, I have 2 sets of congruent right triangles. Since this is the bisector here, I know this triangle and this triangle would be congruent, and this triangle and this triangle would be congruent. And my very last conjecture, the blank angles of a kite are blank by diagonal. Okay, so imagine that symmetry again. Everything on the top half and the bottom half are the same. So it's saying this vertex angle here is bisected by that diagonal. It's cut exactly in half. So I'm going to add a 2 mark here and a 2 mark here to show that those halves are exactly the same. Excuse me. And I'm going to add a 3 mark here and a 3 mark here to show that those halves are exactly the same. So my way to write that, the vertex angles of a kite are bisected by a diagonal. One quick example. Use the conjectures to calculate the measure of each lettered angle. I need to find the measure for angle x and for y. So imagine that symmetry, my non-vertex angle here and my non-vertex angle here. I know right off the bat that they are the same. So y is 137 degrees. And then I remember my polygon sum conjecture telling me that the 4 angles of any shape, the 4 angles of a 4-sided shape, will add up to 360 degrees. So I have 137 plus 137 plus 22, and then see what's missing to get 360. I got lazy, but 360 minus 296 should come out as a positive 64. I typed it in backwards, I got a negative, but x is 64 degrees. That is it for the notes of this lesson. You should be able to go on to the exercises. Just keep in mind that symmetry. This is pretty easy to do as long as you look where it folds in half, create that mirror image, and determine where that matching number would be. Please let me know if you have any questions.